awareness of its surface, but a whole new tour of the Moon that shows how both it and other rocky planets in our solar system have been shaped over billions of years. We'll start with one of the largest impacts, Oriental Basin, a feature that's as wide as the distance from New York City to Cincinnati. Using new elevation measurements, we can clearly see the effects of what is likely the last giant impact event in lunar history, with its outer mountain rings rising many kilometers above the lowest points inside the crater. The interiors of some craters in the Moon's polar regions, like Shackleton, haven't seen sunlight in over 2 billion years. However, new measurements have created our best yet maps of these types of craters, allowing us to see deep into the shadows of this surprisingly young-looking impact crater in the south that's more than twice as deep as the Grand Canyon. Some impacts are invisible for other reasons. Although the ancient South Pole Aitken Basin is difficult to see from orbit because it is so large, new LRO topography maps reveal the largest impact basin in the Earth-Moon system, measuring several kilometers in depth and around 2,500 kilometers in diameter. Only the Hellas Basin on Mars rivals it in size. One of the youngest large-scale impacts on the Moon is the Tycho crater. This fresh crater may have formed only 108 million years ago, when dinosaurs roamed the Earth. We now also have an extreme close-up view of the crater's central peak, revealing a mountain with sharp edges, building-sized rocks, and a central boulder about the size of a baseball stadium. The Aristarchus Plateau is another recent lunar formation that has long interested scientists and astronomers. The crater itself formed in the same era as the Tycho crater, and what appear to be snaking river valleys were actually carved by ancient lava flows. Next, we arrive at Mare Serenitatis on the near side of the Moon. In December of 1972, the crew of Apollo 17 landed in the Taurus Littrow Valley, marking the last time humans have visited the surface of the Moon. With images from LRO's narrow-angle camera, we can clearly see the evidence of that visit. In this image, you can easily see the base of the lunar lander, along with the lunar rover, parked far from the blastoff zone. You can also clearly see the astronaut trails and the wheel tracks left on the lunar surface. We now head to the far side of the Moon, which cannot be seen from Earth. Our first stop is the Compton-Belkovich region, which shows evidence for young volcanic activity in the far side highlands. This feature is unique not only because it is isolated from other volcanoes in the area, but also because it is located nowhere near the Maria, where volcanoes are usually found. Also, on the far side, we find the Jackson crater, which, like the Tycho crater on the near side, has an extensive and complex ray system. In fact, this crater is often considered to be like a twin to Tycho. Finally, the Tsiolkovsky crater stands out as an excellent example of a far-side crater filled with a sea of ancient lava, known as a mare. It is particularly interesting to scientists and other observers because of its isolation from other similar craters, as well as its beautiful central peak. As we continue to study the Moon, our understanding of it improves, giving us new insights not only into how it has evolved over time, but also how other rocky planets in our solar system have come to look the way they do. With new missions, new instruments, and new technologies, we will continue to improve our knowledge of the Moon and better understand the history of our solar system.